Our session today, it's experience and benefits with Multipoint Foundation, and we have Peter Jaberski. Peter is born in Toronto, Ontario. He graduated York University and Ottawa University with degrees in business administration and public administration. So please welcome Peter to the floor.
Thanks, Chris, for that introduction. Yeah, with those degrees, I did start my experience in construction. I ran construction crews out in the east end of Ottawa. Most of the fences were built by me and our companies, just to let you know how that happened when I got into this business. How many people have heard of Trowdetic before, or the Multipoint Foundation? How many have one? Anybody's used one yet? Because I know there's a bunch up in Fort Saffron. Bimatong has a few up there, so there are in the area, and hopefully you'll see the benefit to get more. Where do I click? She's not working. So Multipoint Foundation is part of a company called Trowdetic, and it's one of the divisions. I'll just run through the bit of a history of Trowdetic so you see the pedigree of over 60 years of experience of building unique products out of steel. You see Ontario Place there. There's the JFK Library in Boston. There's a water tower in Sacramento, and I think that's a museum in Pennsylvania. Oh, here we go. Okay, I'm just repeating what this is more detail. This is the architectural division. The dome was built in 1969, and it's still standing, using the same technology. We also done some First Nations projects in the United States. We call this the Turtle Dome in Michigan, still standing, and I think we had some requests to build similar ones in other locations. We also do domes for mine sites. This is one out in BC, as you see. They're quite big. You don't get the idea of the size in the photograph. You have to go out there and see how big these things are. They're massive. It's all using the same technology. Now the foundations division. And this is basically what it is. A multi-point is multiple points on the ground, and you put any structure you want on top. You can put any design. As you see here, this is the shape of a fish. This is up in Dallonly, Northwest Territories. And this is the end product. It's a community center, daycare center, and they're quite happy with it. So that's the flexibility of the system. That's one successful story that you can. It's not just 90 degrees. We can make unique shapes. This is again the premise. It sits right on grade. There's no excavation required, no digging, no trenching, no concrete's needed, no piling. It sits right on the ground. Now you supplement something. See, those have basic base plates, as you see up here, our model. But in certain conditions, if it's more swampy land, then you'll use a timber pad or a supplemental. We've come with a fiberglass base plate, so that spreads the load even more. And this is the principal design. Again, the name Multipoint Foundation leads to the whole premise of the product. It's multiple points touching the ground, but not all of them have to be touching the ground for your building or your structure to be level and square on top. So this is mostly designed initially back in the 80s to help with the permafrost movement up in Yukon, Northwest Territories, and Nunavut. So here you see 1 year you can have a couple of points not touching, then the next year the ground moves. But it's also, the big thing is that it's adjustable. If there's a lot of erosion on one side, you can go and you can adjust just the base plates and the rods. You can come up here later after the presentation, you can see the adjustable rods. That's the whole premise, basically the basic design of that. It's a space frame truss system, however, there's several names you can apply to it, but that's how it goes together. It's our model here, that's an aluminum model. It's easier for us to carry it around, but normally it's a galvanized steel. It's very heavy product. It's very robust, but it's very durable and flexible. And to put it together, it's very straightforward. This took us 15 minutes to put this together, this little Okay, we know what we're doing, so it may take another 5 minutes, it may take you 20 minutes if you're starting off, but honestly, it just snaps together. It's easier than, I keep telling people, it's easier than a barbecue. It's, everything's number punched, all the tubes are number punched, everything goes together. It tells you, the design tells you, if you're doing something wrong, it will let you know. It's all very logical, put together. That's the basic premise of the hubs. That's how the load is distributed, and the bridging between, you see the horizontals and the diagonals there. And its applications are widespread, as you can see in our banner, and here, you can put them on problem soils, floodplains, permafrost. They can be permanent or temporary foundations. Here they're sitting on a cement pad, former building, I guess it was, or former site, I forgot. We've won a couple of awards for this design and for this product, and we're happy about that. We've been recognized. And for a couple of years ago, well, 4 years ago, this was, I think it was here that they won the award for their use of the Multipoint foundation system. The question is, how does it arrive on site? It's very compact. In North America, it comes basically on a flatbed. There's one delivery. You don't have to worry about trucks running up and down the road. You don't have to worry about, it can come on winter roads too. If you have winter roads, that has to be scheduled. You have to time it right, but we do that all the time. Comes in crates. All the crates are already labeled, so you know what pieces are where. You just lay it out and build your foundation, and you can put anything you want on top of it. Again, this is, basic design idea, the principle behind it. There's the adjustable rods, there's the hub, the tubes slip into them, and they can be moved up or down. And you can skirt it. This is a chain link, but you can use other kinds of skirting. This is, in some locations, they want the airflow to go through so the ground doesn't move as much, so the permafrost is not thawing. Here we got a project, I think that's Vancouver, sitting on a parking lot. So there, you know the compaction rate is pretty high, so you don't have to worry about supplemental base plates. And again, just to reinforce the idea, they are adjustable. And also on the top left, you can see where you're worried about your mechanical, your plumbing, and your electrical. There's a lot of space to put that through, so that you don't have to worry about it. Like we can build a chase if you really need one. But most of the time, you can do it this way. We can also, if you have a sloped property, you don't have to worry about building a wall, a retaining wall, or using gambions. We can step it, we can do multiple heights. We've built some as 5 levels high, so it's possible to do. Same idea. It's all adjustable, it's all interconnected. The bridging capacity is all there, so you don't lose the rigidity of the upper level. A couple of ways you can connect your building to Multipoint this is through saddle brackets. This is your standard construction, A-frame construction style. Put your beams in, put your joists, and away you go. Or we can, if your loads are heavy, if you're more than 1-story, 2-, 3-story buildings, we can supply and integrate into the foundation A and I beam. This will give you better load support, more load distribution. Any questions so far? Sure.
You've got that pretty open there. I assume it gets closed up. It's pretty open up there, underneath there, and now is that closed up to keep your water lines and?
Which part?
Well, under your foundation, it's all wide open. Like, do you skirt it? How do you keep?
You can skirt it, yeah. Okay, I'll show you some other ones. Well, you see the top left there. It says modular. That's skirted, right?
Okay.
So you can put any kind of skirting you want, any aluminum
Protect
or
the stuff that's underneath, I would think.
or wallboard, whatever works for you.
Okay.
Yeah. Anyone else? No, we'll keep going. Okay. Again, it snaps together. You don't need special tools. No welding's required. You don't need any heavy equipment. You need a ratchet or a wrench, but that's about it. Level before you start. Again, back to the unique design possibilities with the Multipoint system. It's not just 90 degrees. This is again Northwest Territories. They want it to look like this shape, and we designed a foundation around that. Yes, we use some structural steel, but then we incorporate that into our foundation. Or we coordinate it with the client and they provide the steel. We can go either way, whatever works for you. That's the inside, that's what you get. There's their council chambers. Get a nice look. It's also useful for flood preventions. This is in Manitoba, central Manitoba, north central Manitoba, Wati? Wainless, sorry. Yeah, Wainless, Manitoba. They had constant flooding there, and so they decided to buy the foundation system, and yes, it still gets flooded, but the houses don't get damaged. So that's a big savings for them. So yeah, once in a while, maybe you have to use a canoe to get to your house, but at least your house is there, and it's useful. Happens. This is another project on the Ottawa River, same thing, where you could see, how high she was flooded. You could see the difference. I don't know if you could see, there's discoloration underneath the windows there. So that's how high the water, she got flooded. So we raised it. This is about 3.5 feet, and that works well. This is a retrofit, so you can retrofit them too. So we had to you get somebody to lift the house, you build the foundation underneath, then you lower the house back down. And that's doable. Ideally, you can't lift the house with a crane. If you don't have a crane, you get jacks and pumps and you just move it, and that's possible. You can also use it, this is more during the pandemic era where you needed temporary shelters or temporary medical centers. So it can support that, container style. This is a unique project. As you see, literally the houses were falling into the sea. This is way up in Alaska there on the Bering Sea. The state government there said, we'll just buy you brand new houses inland. They said, no, we want these original houses. There are community housing. We want them moved. So the company got contacted and they came up with a system. Again, lifted the houses, built the Multipoint foundation underneath with a unique feature. As you see on the bottom right, it's a steel skis. So the foundation is sitting on skis. And then we told all these houses inland 5 miles. So and we've had some calls up north where, okay, the bridge is out or the ice roads are out, but there's an option to, if you want to, you can move the house with the foundation in the winter months. It's not ideal, but it can be done. It has been done. It's very durable, very strong. As you can see, this is probably at the port, I think. They built the foundation and attached the house before they shipped it up from Seattle. And so it won't buckle. The structure is solid, secure. There you go. It's sitting on a barge going up north. So it shows you the durability and the strength of the product. You can also use SIP panels. This is up in Arviat, where the home hardware burnt down. It was an emergency, the home hardware just burned down, gone. So we had to design and build this and send it up on the ship before the shipping season closed. So this was done within, 6 to 8 months, I believe, something like that. The speed of this was phenomenal. As you see here, we have a lot of timber pads because they have a gravel pad, but still the compaction wasn't ideal in terms because of the speed of the necessity of the project. We told them to put these huge timber pads just to spread the load more, even though SIP panels are very light. In the end, that's the flooring, and everybody's happy that they can get their supplies now at Home Hardware again. We also go to mining sites, and we provide it not too far from here. Well, that's far. Just north of Sudbury, it's IM Gold mine site. We provided the foundations for the mining camps. We got to change that title, and that went well. Again, the ground there is a combination. There was rock, there was swamp, And the best solution was to use our system because it's adjustable if something moves. And the install was very quick too. Like something like this goes up this went up in about a week. This is, I mentioned Vancouver earlier, so this is housing projects in downtown Vancouver. If you ever go downtown Vancouver, near the stadium there or near the hockey arena, you'll see these 3-story buildings. They're all sitting on Multipoint foundations. You won't see the Multipoint foundation because it's skirted there, as you see in the upper right picture. So you won't see the foundation, but it's there. These went up. These are 10,000 square foot foundations. They went up in 3-4 days, basically. And then they had to do the mechanical underneath and afterwards, but then all these modulars came in and they just put them together like Lego. And what's going to be happening there, those were set up as temporary, and so the beauty about our system is that it can be moved. And what's going to be happening in Vancouver at some of the sites, the developers come in, he says he wants to build something taller, so all the modules are going to be taken off, again, in backwards order, and then the foundation is going to be moved to another site, and then the module is going to be restacked. So, again, another feature of the multi-point system. Just more examples of housing projects in lower BC, near Vancouver, in around Vancouver. And the heights there, the height varies. It can vary from, starts at about 3 feet. Again, this is just our model here, but usually starts at about 3 feet, 36 inches. It can go higher. We've done one project that's as high as 9 feet. Okay, that brings me to the end. So again, it's designed as a floating slab. So it's not a living thing, but it's floating slab. It's a raft. It's everything, once the building is locked into the foundation, it works as one unit. So if there's any movement, everything moves in plane. So your doors will still close, your windows won't crack. They will open, you won't get cracked drywall. Minimal site prep, again, you want the pad to be as level as possible and as compacted as possible. You want to get rid of the big rocks and the roots. Everything's custom designed, nothing is off the shelf, even though, unless you have multiple buildings of the same design, then, but for that design, but nothing, you can't call and say, hey, I got this. No, we need to see the loading of the building, and we need to ideally see a soil report or something to understand what's going on the ground. I just mentioned the height possibilities there. It's very quick to assemble, as I said. This stuff goes together. I was able to train people who had no construction experience with Habitat for Humanity in another location, and within a day and a half, they were telling me, Peter, you don't have to even show up. We know what we're doing. They just followed the design. It's that straightforward. Again, I went through that. It could be assembled, disassembled to different sites, and it's happening. And where we go. I'm just repeating myself here, sorry. I got ahead of myself. And yesterday I went out to see Mount McKay. So when you think about multi-point, think about something solid, permanent, like a mountain. It's solid. It'll be there for a long time. And that's the presentation. Any other questions?
Warranty.
Sorry?
Warranty.
Warranty? We've never had warranty issues. We never had to, honestly. We don't. There comes with a warranty, but it's never been. We haven't had any failures.
How long is it?
What do you mean?
The warranty.
Technically, the warranty, we signed it, for 1 or 2 years? If something happens, it will go within the first 2 years. After that, everything's galvanized, everything's, tested. Sometimes, if it's a very intricate foundation system, we'll actually put it together in the factory to test it to make sure that it goes together, and then we'll ship it out. So that's a good question. Sorry.
What's your average cost per square foot?
Yeah, we start single-story buildings. We start at about $30 a square foot. That's without seeing any drawings and not knowing what your soil conditions are like, but that's your starting point these days.
It looks really solid, and it's a great idea. I've never heard this before today.
Oh, okay.
And I'm looking at this going, holy shit, I like it. But the only thing that, and obviously I'm not an engineer, I'm a banker, but if that is sitting flat on the ground and not fastened, it's just sitting flat, right? On a bunch of feet?
Yep.
And you got a great big windstorm, is it engineered to take what? How much can it take?
Well, it is engineered to handle wind loads and snow loads. Now, there is a supplemental thing, I didn't put it in the presentation, I should have. It's, you can add something called man array anchors or duckbills to the corners of the foundation, so it'll keep it in place, yeah. But most of the time, the weight of the structure, because it's solid steel, and then the building on top usually keeps everything. Unless the height, if there are three stories, yeah, then sometimes you will get the duckbill recommendation.
Well, on top of that, I was just wondering, could you combine that with screw piles for a more sturdy into the ground so it doesn't blow, it wouldn't be moved or anything?
Well, no, screw piles, well, you see, those screw piles won't work with this system because they will act independently, and then this will affect the bridging capacity of the multi-point system.
Okay.
There's no need for that. There's no need for any extra. You can put again, that's a model. On our bigger base plates, we have pre-drilled holes. You can put rods into the ground, but again, there's no need for any extra equipment or any extra drilling. Sometimes when you go on brownfields, you're not allowed to go into the ground. This is in the city of Vancouver. That's why they went with us, because they were in the city. They were former gas stations, former parking lots, so they're former industrial sites, and you don't want to dig those up because then you have to go to a different landfill and you don't have to do any remediation. So these went up fast.
Well, that's why I was actually thinking screw piles, because you don't have to dig anything, you just drill it.
No, but even in brownfields, you're not allowed to even,
Oh, okay, yeah.
you're not allowed to go into the ground.
We've done projects in Alaska on the Shishkar Sea where there's hurricane force winds, so it's not gonna fly.
That's a good question. Yep. Yes.
On your system there, how does that work with modular homes? 16 by 75 foot. What I'm concerned about is the run of the wastewater lines, the 3 and 4 inch lines, and the water line.
Fair enough. Yeah, no, that's good. Yeah, we worked that out with the engineers.
Do you have like runways through that system, or you gotta climb through all that steel?
Depending on what you order. We can build, we call it a utilidor. It's basically a vertical chase. We can build that in. But then the price is different. The pricing is because you're using a lot more structural steel in that case. Yeah, depending on your runs. But we can, we need that information too, where everything goes. So, but that's, we do that all the time. So it's a good point to think about.
Do you have a diagram or a picture of how that would look like?
Yeah, if you come by tomorrow to the booth, I'll have something ready for you.
Okay.
Yeah, we'll have a booth here tomorrow, so
Alrighty.
please come by. Yeah, I can show you more information about that. At the back?
For these foundations, a lot of times if it's a modular application in the north, there often isn't cranes on site to lift these houses onto or set them like in other areas.
Right.
Do you guys have a solution that allows for blocking and jacking and sliding of them or something like that to go with them?
Sure. It happened beginning of this year. We working with the Northwest Territories Housing Project way up north. This was in January. I was up there for resolution. And the modular supplier and the general contractor, they came up with it's a railing system basically. The flatbed comes with the modular units, and then they raise the flatbed to the height of the foundation, and they just roll it off using winches and jacks. So there's a solution to it, yeah, if you don't have a crane or a helicopter, yeah. And it works, and how many, we did half a dozen locations like that in the winter.
Any more questions for Peter? Oh, see one here.
I can show you that. Again, come stop by the booth and I can show you that railing system.
Yeah, you showed a picture there of a round building.
Round building, yes.
How would the cost of that compare to a square building of similar size?
To which?
The cost of the round foundation compared to a square foundation
Oh, I
of
wouldn't be able
similar
to
size?
quote you. That depends on project to project. I really, you know, it's more than what at $30. It would be much more. Again, send us the drawings. We can give you a ballpark. You know, we can give you an idea from our design team. But that may take several days to get an answer for you. If you have a design, a sketch, or anything, yeah, come on by tomorrow.
Any more questions for Peter from the crowd? Oh, one more.
How do you deal with point loads within a building if there's a large open area with a large, beam and post? I guess you'd have to design that into the.
Yeah, that's
system.
an engineering question. I'm not the engineer, but they will. In some of the pictures, I think you've noticed that sometimes the spacing between the pads is tighter and sometimes it's wider. So that's where the variation is. Or if the point loads are very high, then we'd probably suggest the I-beam on top. Again, that's a project by project result. Good question.